So good morning, everyone. Well, I'm glad I'm not the only one presenting here. Everybody here should be nervous a little bit like me, okay? So that's a very good start. Well, I suppose it's like Aaron, being the last one, well, the best saved to the last anyway, but I had to change my talk a little, during the week. So it was only ready last night. And as you can see, the title did not change because we managed to make it work with what I'm going to say today. And the focus will still be how we can, build these technical models to that will provide some sort of intelligence, that community can use, and why and how. And I suppose, okay, I suppose what I want to start with is some sort of a story. And basically, it's my story of how my research, career has evolved around particular questions and how an engineer somehow ended up working a little bit on co-creation, right? Which is by itself, it can be a little, it can be interesting too, right? I started my career as, as a modeling engineer, right? Working on seawater intrusion for Gaza coastal aquifer. And I had a really exciting task of developing a detailed model that can be used to understand seawater intrusion and predict future scenarios. But for you, if somebody works on hydrogeology, that's a very complicated task because you have different densities, you have different temperatures, you have different water qualities between the sea and the underground water. And there is a lot of uncertainty in the bedrock geology. And that's by itself is very exciting, sophisticated task, right? So as a technical person, I was jumping up and down to start my career. I considered myself lucky, working on this. And we've managed to build this a very sophisticated model. It was the spatial accuracy was 30 meter by 30 meter. We managed to dig around across Gaza 200 observation wells. We managed to get to the logs. We looked at the geology. We looked at all the layers, and the model was getting over parameterized. We got every single parameter that you would think of. So we got a pretty good understanding of the seawater intrusion and how groundwater flows and how different pumping scenarios would affect this. And obviously, we had to run a pretty long validation campaign and calibration campaign. And we've, once we got the results and we start looking at the scenarios, it was really depressing because we've discovered it's pretty bad. As you can see, the predictions were in 2080 that almost 90% of the aquifer was going to be seawater, and unfortunately proven to be true. We never for the people who are doing the presentation in Gaza, we never actually predicted that kind of scenario that we're in today, which is much worse than what we've predicted at that time. But it's still it was pretty depressing, but at least we had a tool to look at the management scenarios and what will work. Okay, but unexpected things happens, right? While we're looking at the monitoring, and trying to make sure that there is a continuous validation coming from the field for the simulations that we do in the, on the model, we discovered that one of the observation wells down in the south was giving us average, groundwater level would have been around between plus to minus 2 from sea level rise, around these numbers, right? That would be a normal things. But at the south, we start getting numbers around, from one of the wells around minus 16, minus 17s, which is for you, who works in geology and hydrogeology mainly, you would know that only given an indication of cone of depression, right? There is a lot of overpumping happening in a very concentrated area, which will bring the groundwater level to extreme depth, right? Which obviously means one way, it's a matter of time where the sea will come in and will be irreversible with such an extreme event. So, you cannot really reverse it, and we cannot have any management scenarios not going to work. So we started investigating and looking what is the issue. And we discovered that, well, it's a very agricultural area. To produce food for 2 million people, they had to, do a lot of agricultural activities. And we discovered that there are 150 of those illegal wells that will pump around like 1,500 cubic meter per day, which is a pretty number for a very particular area that has already 150 wells that we know nothing about them. And obviously, to be able to look at management scenarios and what we want to do, we had to kind of like get more information. The more we start getting closer to those communities, the more we start getting angry farmers. And in like any communities, like you don't want to really like be in the wrong side of an angry farmer, angry community. So it was pretty tough. But at that time, I was a very technical person. Like I didn't really, I didn't want to didn't care much. I did care because I wanted to keep building that model with the team, but I didn't think much about it. But there was that particular question around, well, it's a challenge, right? Why there is no trust? Like why they thought like it will be used as an enforcement tool rather than like a tool of dialogue, right? Why, they felt that they need to protect their livelihood by protecting those water wells. And why they thought that there is no trust at all in us understanding the full picture that the community needs food. So therefore, we will have to protect them and find a solution for them to keep providing the food for the community. So the full story didn't make a lot of sense for me, but it was the extreme kind of like conflict that the only thing that protected me is basically my family connections over there, right? And kind of like the question about you know building the models, it's a very technical task, but can we do it with the community? Can the community help us parameterizing the models? Which kind of like, it started like coming to me because that will obviously add to those levels of a trust, safeness, and also you will be maintaining the Earth system boundaries as this paper, it's a very good paper in Nature, actually, if you'd like to have a look at it. And kind of like that particular question start coming to me, but again, I was young engineer, but I didn't, very technical, and I would never get to these kind of sophisticated kind of like research questions. So the challenge, like when I reflect now, was around the trust. And I kind of like had that idea that if we start building those models, parameterizing them with the community, you'll get to some sort of an interaction between, hydrology, technology, and citizens and society. And that will give you some sort of citizen science kind of activity, but it will be towards building and parameterizing technical models that will be used as tools of dialogues with the community. Because if they help building it, most likely they'll trust it, and most likely they'll be able to use it as a way of testing their co-designed what-if scenarios. Because what is management is practically what-if scenario. We suggested we find a tool to actually test it. Does it work or doesn't before we implement it? Nobody will go implement multi-million projects on management for an environmental issue without actually testing that. And the tool that we use to test that is basically models. So that question kind of like around why do we build models about communities instead of building models with the communities is kind of like getting a little bit more kind of like into me. So a model developed with people can become a tool for dialogue, exploration, testing, what-if scenarios. And most likely, once it's built right, it will provide you with early warning kind of like tool. Because once you build an ecosystem of real-time observations, and link it to your model pretty much, if you have the computational capacity, will be providing you with early warning flags. And that's what your ultimate kind of goal as a modeler you want to see. Like you want to understand the phenomena, then you want to test what-if scenarios around solutions. And ideally, once everything is all right, you actually have a tool that monitor the system and then keep moving on. And that works for either groundwater modeling or like flooding modeling or like air quality models. All those models conceptually can be the same, right? And as my professor, Kapatalan told me, they're all wrong, but we do our best to kind of like make them helpful. And that's kind of like what we do, right? apparently, if you build them right, going through those what we call the 5 bridges of death, right, to provide some sort of early warning chain, and you involve the community, you'll end up having that tool that will provide you outputs around like around early warnings. Now here we go. Moved to Ireland after that, and to do my PhD, finished my PhD. If you look at my publications, you can see like I worked a lot on the Shannon River catchment, which is the largest catchment here in Ireland. And I got lucky enough, maybe not, I don't know, like I worked with a big engineering firm focusing on the flood risk assessment, a big project called CFRAM, right? And I was working on the Shannon River catchment, which is, pretty big catchment, have a lot of area, but also had a lot of farming communities and farming activities, right? Again, my task was very technical. So I was building those models and, excited about the models, looking at climate change scenarios, how we can get the climate change signal into the model, and how we can produce those sophisticated climate-induced risk maps so the community can know where most likely we need the interventions. But again, it was, it was interesting challenge because I found myself, yes, an engineer building a technical model. It had nothing to do with a public consultation task. Like I was very technical, like I was pretty like on the first line of the chain of building a model, right? So, but one day I had to go and attend a public consultation. Found myself in a small town in the Midlands, trying to tell some farmers that according to a certain scenario, with a certain return periods, potentially their farm or their house in the farm might be flooded. And therefore, if those results gets published, their house or their farm, they might devalued at best case, and most likely they're not going to get insurance. Which you can say, like, you can tell, like, with my funny accent, that worked really well, right? Yeah, it wasn't fun at all. And it was very tense meeting. And again, the science itself was exciting because we built this sophisticated model, but it got built for one consultation event, or in most cases, like two, like because we had to do the second one because the first one didn't go well, right? So again, this time it got a little bigger because obviously in Ireland the governance is a little bit different compared to kind of like in Gaza, and it got big as far as it went in a debate in the parliament, okay, which we call directors here, right? And all those are public kind of like information. You can go and listen to the debates, and you see how heated those debates were. And there was a kind of like some sort of a report published around kind of like the summary of those conversations. And what I kind of like got to me at that time is standing in front of farmers explaining, those scenarios was a tough job. It would have been easier if those helped parameterizing those models. So like more I started getting that actually parameterizing models is not really a technical task anymore. And the question around, can we build these models differently, start coming to my mind. With somebody who has a PhD with a valid research question, most likely going to get funding. And that's what happened, right? And I moved back to academia again. So what we did is kind of like, can we move beyond asking communities to comment on finished models? Can we instead involve them in shaping those models themselves? And that kind of like a central part now of what I do. I do very technical tasks, but I do them together with the community. And I kind of like try to explain the story that building a model is societal, political, position more likely, more importantly than a technical task. The technicality, you can achieve it. There are dummy models that you can get built very quickly, but those are also useful if you build them together with a community. So you can have them as some sort of a tool of dialogue. So the question around how do we build those climate intelligence that people actually can use? To kind of trust first, and then once they trust, they can use to trust you to test their potential solution scenarios, which we call them the what if scenario in the model. And therefore, you can have more healthy kind of conversation that is two ways, that everybody understands that you want to get some sort of a solution that would not impact the community, but also preserve the resource, which is the end goal, I suppose, right? So the idea around those models is very interesting because we don't become, from my opinion, that's my statement, climate resilient by building better models for climate-induced hazard alone. We become climate resilient when we connect better models to better sensing or real-time data collections and better ecosystem for better collective decisions. So models, in order for them to work, on a public domain, they'll have to be a tool for public decision, public consultation, for tool of dialogues. And that's kind of like the main idea. My focus always was on the coast, simply because where I'm from, where I lived, and my experience. And in Ireland, that's a given, I suppose. And for me, the coast concentrates the climate story. Let me check how we do. Yeah, we're good. The coast concentrates the climate story. You can have flooding, you can have erosion, you can have different types of flooding, fluvial, pluvial, coastal, groundwater. So there is that question of joint probability analysis of climate-induced risks, because climate risk is a collective of things, right? There's multiple risks happening together, and then you put them together and you try to say, what is the worst case scenario that I can adopt for? Because apparently you cannot afford adopting for everything, right? And then hopefully you build such a model to understand that risk that will help you taking a decision on the intervention. And in order to take a decision, you'll have to stitch all those dots. Now, this is basically my talk of the last year. So if you are interested in that, there are recordings that you can access. But in theory, my understanding of how we can react has to be systematic, and we have to go through some sort of a co-creation mechanisms around building probably living labs that is around system thinking. I'm not going to go through this because, again, if you're interested in this particular way of acting, that talk is still, I believe, available. But in essence, what you will need to do is you'll have to have 4 steps, kind of to build those models to serve people. So you'll have to kind of some sort of you need to see what the coast does. And that will include satellite observations, local sensors, citizen science activities, crowdsourcing from social media. All of those are parameters that we use in modeling, right? And the more real time you get them, the more useful they are. And then you need to co-create the scenarios and the model's parameterization to be able to simulate. And then you need to listen to the people on the results of the model and if they make sense or not, because local knowledge is gold when you calibrate and validate the model. And I have loads of examples if we have time for them, right? Now, so the idea is about moving from climate-induced hazard modeling to the observation with the community, to the participation of those communities in building the model, and finally, for a collective model that can use those tools that often seen as some sort of tools of law enforcement, really. And the question is not about what solution we prefer as engineers. The question is always about what exactly we're able to see together with the community that is going to work. And to answer this, you would need a lot of time and engagement with the community. And I suppose the model is one way to see things because it worked in a number of years. you know, as tools of monitoring and simulations and understanding, but local, environmental parameters, observations, with the question of the scale in mind is important. And now becomes like, okay, you say like we're going to build those models together with the community, but how we build them? Like, would the community understand the parameterization? Where there is a lot of important models parameters that I believe you cannot really get away without now, I believe you cannot get away without kind of like co-creating. And the first one is the scale of the model. The scale of the model, temporal scale, and spatial scales are very important parameters. They determine like the level of your understanding of certain area and the amount of computational power that you would need. The modeling technology is very technical parameter. But when you think about it, it's more social and political parameter too. Because, if you change the scale of the model, different results will become, risen up. And maybe it doesn't help, or maybe it provides more details that is not useful to the conversation at this particular stage. And maybe it's just like the community is not interested in it. So why scale, from my point of view, is not only technical detail, it's political choice, because climate information only becomes useful for cities when they're basically down scale to the right scale. Like either like a 1 meter by 1 meter or to the street level, because that's very different. 1 meter by 1 meter, you can get one whole household like interested, trying like to understand a little bit more than you. A street level, you might get a small community that, they have different types of dynamics that you need to deal with. So the scale of the model by itself, it's a choice that will have to be co-created. And we've tested this idea in this paper when we looked at multi-scale modeling for coastal cities. So we took examples from Spain and from Ireland, and we applied different scales for the same type of modeling problems. And we tried to kind of like optimize those with the communities. And it was very interesting because everybody was getting pretty heated around like choosing the scale of the model, which is pretty much very technically questioned. What is the size of the pixel? And what is the size of the time step that you're simulating? Another thing that is around that should be co-designed in terms of model parameterization is, do really each hazard matter? Like, do we need to have that sophisticated model that models all the hazards? That's again a very technical question, because how would you know which is the worst case scenario? But again, not all hazards actually matters, because when you put them together, the worst case scenario might exceed the hazards that you're losing sleep on, right? So future coastal flood hazards emerges from interactions of storm surge, high tides, and sea level rise. So if you take the high tides and sea level rise, in some locations in Ireland, you will exceed the climate-induced hazards component in the middle. So you might take those and run with them, right? Because that will already give you the worst case scenario that you'll be to, I'm not saying that's the case everywhere. I'm just giving kind of like the logic why not every hazard is actually worth the fight about it. When you have that fight with somebody and then you're like, it doesn't really matter because like it's not going to affect anyone. And that's kind of like the story here. So, we've kind of like tested that in this paper where we looked at projecting extreme sea level rise for the northwest of Ireland under different climate scenarios. And again, we looked at kind of like co-parameterization of the models. And it was very interesting because we end up like everybody agreeing that some of the hazards not really worth looking at them. So again, the hazards being modeled is important political, social kind of aspect, not only a technical aspect of the model. So yet, even the best monitored coastal line does not tell us what people fear, trust, or accept. So therefore, like you might even co-parameterize those models, but the model at its best, once it's co-designed, it's not going to tell you what, I would fear or what I would accept, or would I trust the output or not. So it will have to always be done together in a parallel way. You cannot just build a model and go have a consultation, couple of them. If the first one doesn't work, you have another one, and then you move forward. You'll have to have a parallel process, because even if you build the tool of dialogue, that tool of dialogue, it'll have to be taken to a right round table for that dialogue, similar to what Thomas shared with us, right? You need to set the scenes for that dialogue. That dialogue, there is a lot of technicalities. And once you use a model as a tool of dialogues, there are some technical engineering parameters that you would need to have some sort of a trusted process that everybody trusts to be able to explain it. So that takes you to the question that we need to watch the change and account for it and keep communicating it as we develop and communicate and update those models. And adding to that, the coastal line is actually a life system. We should be looking at its boundaries, right? And again, boundaries and boundary conditions are very technical tasks. If any of you studies like numerical modeling and finite element models, boundaries conditions are where I enjoy and find myself. I know that's weird, but that's, boundary conditions is a very technical task, because it provides you part of the solutions of mathematical equations. So you'll be able to resolve the equations across all the model domain. So it's a very technical task. But when the system is dynamic, you would need to include that dynamic of the boundary of the system inside the model, and you need to make that clear for everyone and why. Okay. So another technical question that also very technical, but would need to be co-created, because if you don't, you basically going to create more trouble. And we basically, in this particular paper, we looked at that in 3 beaches in Sligo. So then more in Scorn and Strand Hill. And what we've done over there is we looked at the boundary and how dynamic it is. And because it's dynamic, the understanding is interesting, in terms of the dynamic between the stakeholders. We had different types of stakeholders without getting into the details. Some of them would have deep pockets, some of them wouldn't. Some of them would have businesses, some of them wouldn't. And the very, scientific experiment that we had to run, it turned into some sort of public political meetings, which was more interesting for us as well, right? With this particular paper, we looked at, the shoreline changes and how you would need to co-design a dynamic boundaries in order to be able to kind of detect that within a model. So I suppose the last parameter that I want to talk about that is not only a technical engineering problem, it also has to be co-designed, is kind of the point of modeling is not always the most detailed model. You don't need to have the most sophisticated model every single time, the most detailed model. It's the model that answers the decision question. So the decision question have to be clear from the start. People need to know exactly what is the end goal. Are you going to use this, as you're saying, like a tool of dialogue, or it's going to end up being a law enforcement tool? Or it's going to be like a tool that would be used for insurance companies, or going to be the end goal would have to be clear so people will understand what is the decision that would be taken. And we tested this theory in this particular paper, where we're looking at assessing the Bayesian scale modeling for projecting storm surge extremes in Donegal Bay. So we had a small scale model, Donegal Bay or by itself, and then we had an extended model, including half the Atlantic. And we had a full model that includes the whole Atlantic, right? And we run a consultation, we managed to actually answer the question for the decision that was to be taken by the community from the simple model that we developed only for the Donegal Bay. So the efforts and the money and the over parameterizations that we had to go through the big models was not really needed. And it added more questions, more complexities, more parameters that would need to be to be looked at. So again, that's very technical question, but very political, social problem that would need to be answered together with the community. So to summarize, model parameterization is not just an engineering problem. It's a spatial scale problem. So which communities are, a spatial scale that would need to be solved with the community. And that's mainly because which communities are included or excluded. When you look at the scale, you will be answering those. And another parameter is the model boundaries. Where does the responsibility begin and ends? Communities needs to know. Like again, when Thomas talked about like the Dundalk Bay and who deal with what was a bit confusing. It's exactly the same problem here when you parameterize the model. Where the boundaries end will provide who's responsible of taking a particular decision. The temporal resolution is very important. Yes, it's very technical, but also is very, community related. So which events matters? Is it the one after 100 years or the one after 50 years? Or maybe the one immediately is happening like in 10 years, which sometimes like some people think things that are not very immediate, but when you model, that's basically what you think. And then not every hazard matter. So the joint probability assumptions needs to be clear and co-created, because you might think that some of those hazards, they're not really worth it because there are much more worse ones that you need to look at it. And then the scenarios are important. So once we model those hazards, here the communities, how we actually move towards taking a decision. So how we actually use those tools. And again, like that will take me to the last year kind of like talk, which again available online. But I kind of like give some sort of an experiment that we've done recently, which is an update from the last year. It's we've tried this what we call the fuzzy cognitive analysis as a method. So the move between what the coast does as an environmental system to what society feels and chooses, kind of like be a whole system mapped, and those systems they interact with each other. Some of them will impact things positively and some will impact things negatively. And in order to be able to take a decision, you'll have to map every single system of those systems together, understand their dependencies together with your model to be able to take a decision. Otherwise, you'll be missing a lot of things. And once you miss things, it's very easy to lose the trust. And that would need to be kind of like taken into account. With that, I kind of conclude that the way I see how we build the climate resilience is, I cannot divert from equations really, but climate resilience for me equals to better hazard models, plus better sensing or real-time collecting, plus better ecosystem and better collective decisions. That's my presentation. Thank you so much for your attention.